Okay, good evening. Welcome to
MinuteMath number 87.
MinuteMath number 87. Today, we're taking a look at a really cool problem from the Mathematical Association of America's MinuteMath blog. And this one is a logic puzzle. I don't think we've ever done a problem like this before, so it's pretty neat to do. Amy, Bill, and Celine are friends with different ages. Exactly one of the following statements is true. You don't know which one, but only one is true. Bill is the oldest. Amy is not the oldest. Celine is not the youngest. Okay? Exactly one of those is true. Rank the friends from oldest to youngest. Okay? How do you want to approach this problem? Well, first of all, do you understand it?
Yeah.
Okay.
Actually, if all three were true, it would actually work.
Okay. It would?
Yeah. If all three were true, then it would be Bill, Celine, Amy.
Okay. If all three were true, I guess it would work. I hadn't thought about that. Okay, that was a good thing to notice. But it turns out they're not all three are true. Only one is true. Okay, that's a good observation. So how do you want to proceed with this problem now?
Well, you could see if statement number 1 is true.
Okay, that's a good approach. Let's just go through. We don't know which one's true, so let's just check what happens if number 1 is true.
So it would be, you have two choices. You can have B, A, C, or B, C, A.
Okay, well let's see. Remember, if the first one's true, what do we know about the second one?
The second and third ones aren't true.
Okay. So what does it mean if so if 1 is true, Bill is the oldest. Amy is not the oldest. That one's false. So what does that mean?
It means that this one doesn't work.
Why?
Because Bill is the oldest and Amy is not the oldest. It says Bill is the oldest.
Okay, that's true.
And Amy is not the oldest, which is false. So that means Amy is the oldest.
Aha! Bill is not the oldest is true. That's what we're assuming. This one, Amy is not the oldest, is false. That means Amy is the oldest. Oh, but wait a minute.
Bill is already.
Bill is already the oldest. Okay. So we know number 1 is not true.
What about number 2?
What about number 2? Okay, so now let's assume number 2 is true, and that means 1 is false and 3 is false. Okay. So what do we know now?
So Amy's not the oldest.
Okay, Amy's not the oldest.
We could have Amy in the middle. But Bill would have to be here.
Okay, why? Why would Bill have to be there?
This is false.
Bill is the oldest is false, which means what's true?
Bill is not the oldest.
Bill is not the oldest. Okay, so Amy's not the oldest. Bill is not the oldest. Okay, what about this one? What about statement 3?
Celine is not the youngest. Yeah, we have that. But that's false, so Celine is the youngest.
Aha, so Celine has to be the youngest. Okay, so Bill is not the old. We're assuming number 2 is true. Amy is not the oldest. Okay, so that means Bill is not the oldest, and Celine is the youngest. Okay, so can that work?
No.
Can Celine be the youngest if these two are both not the oldest? Why?
Because these are both not the oldest, so one of them is going to have to be in the middle, and one of them has to be the youngest. And Celine is the youngest.
Celine is the youngest. Okay, so now we figured out which one has to be true.
It's number 3.
Number 3 has to be true. So Celine is not the youngest. That's true. What's true about Amy?
Amy is the oldest.
Amy is the oldest. And what's true about Bill? Bill is not the oldest. So we know Celine is not the youngest. Amy is the oldest. And Bill is not the oldest.
And
there you go. Amy, Celine, Bill. ACB. Okay, so how did we solve this problem?
we went through checking if each statement is true.
Okay, we read the problem and it said in fact exactly one of the following statements is true. We didn't know which one, so we just investigated. If number 1 was true, that would mean Bill is the oldest, but these two would have to be false. Amy is not the oldest is false, means Amy is the oldest, right?
Yep.
But we already had Bill as the oldest, so number 1 can't be the only one that's true, right?
Yeah.
Okay, so now we move to number 2. Amy is not the oldest. This is true. Okay? Bill is the oldest is false, means Bill is not the oldest. So Bill is not the oldest and Amy is not the oldest. Celine is not the youngest is false.
False.
Means Celine is the youngest. So we have 3 spaces. Celine has to be here, but neither Amy or Bill can be here.
Bah.
Bah. Okay? So now we move down to number 3. This one's true. This one's false. This one's false. We know this is going to work now, right? Celine is not the youngest, so Celine can't go here. Amy is not the oldest is false.
So Amy is the oldest.
That means Amy is the oldest. Bill is the oldest is false, means Bill is not the oldest. So we know Bill is not the oldest and Celine is not the youngest.
So Celine has to be
Celine has to go there, Bill has to go there, and it works. Okay, good job. I think only about 20% of the people got that right. So that was a tricky one, but we went through it systematically, right?
Yep.
Systematically is the way to go, especially on logic puzzles.